Hello everyone, welcome to Chapter 10. Chapter 10 we're going to cover correlation and regression. And I'm going to cover all of Chapter 10 in one video because Chapter 10 is a little bit, I hate to use the word easier, but I think it's actually a little bit easier than some of the hypothesis testing we have been doing. Chapter 10 is a little more straightforward in Excel and a little bit easier to work with the data and a little less interpretation, but at the same time it's still statistics and it's still challenging. So please read the chapter, especially on regression. Correlation is fairly easy to understand, but really put some time in on the regression in terms of what we're going to be doing there. I'm going to start with doing a simple correlation on a set of data. I'm going to use a problem in the text that's very similar to your homework. In your homework, you're actually going to have to do a couple of problems. They're pretty quick once you see how we do this, and I thought you'd have the time this week to do a couple of them, and I think you'll do just fine with that. So let's start with problem 16 in section 10.2. So we're going to go chapter 10, section 10-2. We're going to do problem 16. And that would be on page 551 in this edition of the text. So what we're going to do here is compare the heights of presidents and presidential runner-ups. The problem says theories have been developed about the heights of winning candidates for the U.S. presidency and the heights of candidates who are runners-up. Listed below are the heights in inches from recent presidential elections. Is there a linear correlation between the heights of candidates who won and the heights of candidates who were runner-up? So let's go ahead and do winner, and let's do runner-up. And let's enter in these numbers, so 69.5, 73, 73, 74, 74.5, 74.5, 71, and 71. Now let's do the runners-up, which were 72, 69.5, 70, 68, 74, 74, 73, and 76. Okay, so now we need to run a correlation on these two. Rather than use DDXL on this, I'm going to use a regular Excel descriptive statistic, which we can get from data analysis. And I'll show you how to do that. This is just going to be a little easier than the DDXL in this particular case. So we're going to go up here. I'm under data, as you can see. I'm going to go to data analysis. We did this in the beginning of the class. And I am going to select correlation. Okay? And this is going to let me know if there's a correlation between these two sets of data. We hit OK, and it asks for an input range. And in this case, I'm going to do labels in the first row just because I like to do that for correlations, and it asks you if the information is in rows or columns. In this case, it's in columns, and the label is in the first row. And then the output range, I'm going to set to be right next to it, right there. And let's hit OK. And there you have it. Expand that so we can see a little bit. And the correlation between winner and runner-up, the number we are looking for, is negative 0.22093. Now, whenever you do a correlation, you're going to get one important number, which is right here. And these other numbers, you can just ignore, right? This is the one you care about. And this number will always be between -1 and 1. The closer it is to -1 or 1, the higher the correlation. The closer it is to 0, the lower the correlation. And if it was at -1, that's a perfectly negative correlation. And if it was at 1 exactly, it would be a perfect correlation, positive correlation. You almost never see numbers that are actually -1 or 1 because the data sets would have to be identical. At best case scenario, if the number sets were identical but just a hair off, you'd see a 0.99. But in this particular case, we're at 0.22, which is not a strong correlation. So we can draw the conclusion that there is no relationship between the heights of presidential winners and runners-up. Normally, people always ask, what's the threshold of a positive correlation, of where you could say there is a correlation? Well, it's really up to the individual researcher, but you won't see anybody claiming a positive correlation with numbers below 0.5. And even once you get above 0.5, until you get into the 0.7, 0.8 area, you're still kind of walking on thin ice. So we can say for sure that there is not a correlation. But we're going to use the same set of data for the next section. So we're just going to keep it up on the screen. We're going to do regression. I highly recommend you spend some time with regression. Regression is a fairly complicated subject, and it's a fairly complicated method by which it's calculated, but it's fairly easy to do now. The thing with regression was, before spreadsheet programs and computers, it would take research assistants in months to do one regression problem. And in this particular case, we can do a regression problem in a matter of minutes, or even seconds once you've done a few and can move quickly. We are going to move on over to section 10.3. I'm going to change that 3, and we're still going to be on problem 16, and we're on page 569 in the current text. I'm going to go ahead and delete that correlation data, and I'm even going to get rid of the lines there just to be nice and neat. It's like it was never there. Okay, back over to data. Now, the question here says, find the best predicted height of runner-up Goldwater, given that the height of winning presidential candidate Johnson is 75. Is the predicted height of Goldwater close to the actual height, his actual height of 72? So what we're going to do, what regression allows us to do, is to look at two sets of data and how one set of data predicts another set. And so if we know the height of a winner, can we then figure out the height of a runner-up? And that's what we're going to find out. So we know the height of the winner is 75, and we want to know what if we can actually predict something close to Goldwater's height of 72. So what we're going to need to do is run a regression. So we're going to go to data analysis again, and then we're going to slide right down here to regression, hit OK. And we're going to make sure to input the Y range, and I'm going to put the runner-up as the Y range, because that's what we're aiming to determine ultimately. And in the equation that we're going to use in a minute, we need the variable we're going to determine is Y, so we're going to put this runner-up as the Y range, and we're going to put the X range as the winner. Okay. And I did not set labels, which is okay. We'll just do it this way to show you the difference. We're going to do the output range. It says D6, which is just fine. And we're going to go ahead. It says I'm going to unselect line fit plots. We don't need a graph to do this. I'm going to show you how to do it with an equation, which gives you a more precise answer. Well, actually, I'll change my mind. I am going to do that so we can double check our answer. And then we'll go ahead and hit OK. Okay. And it's kind of hard to do this when it's this big. I hate to do this to you, but we want to see that graph, and I'm going to just slide that graph over to here, which will help us out a little bit. And if you right-click on one of these, you can add a trend line. Just that all looks good, so we're going to hit close. And you can see that there's a trend line that runs right through 72. So it looks like we might be in the ballpark, but let's go ahead and do the math. Okay, and when you run the regression, you get all this data, but for this question, what we care about is the intercept. And using the equation from the book, what we're going to do is take this cell here, and I'll open it up here so you can, it's not going to let me do that. Let's go ahead and expand this so you can read it. The coefficient. So we're going to do the intercept coefficient, so we're going to go put that cell, and we're going to add it to this cell, and we're going to multiply that times the number we're trying to predict. And the answer is 72.2, which is very close to the number that we were looking for. The question asked us if the predicted height is close to its actual height. Well, the predicted height in this case is 72. And the actual height happens to be very close. So, things worked out pretty well in this particular case. These are very similar to the homework problems you're going to be doing. Please contact me with any questions as always. I know that the regression could looks a little intimidating at times, but if you spend some time in the book understanding what it is and what the parts of it that you need to use, because obviously you don't need to use all of this for these questions. If you understand the part you need to use, you should do just fine.